Hello everyone, this is Qianxu from CCI. In this video, I will discuss my Coding3 Final Project, Language of Flowers, Unspoken Love. I made a deep learning image classification project based on CNN, and the function uses the trained model to make predictions. Users can upload pictures of flowers on the user interface, predict the type and output the corresponding flower name and its flower language. The idea of the project can be divided into several main steps: data preparation and pre-processing, model training, model development, and interface development. At the beginning, I found a suitable dataset on Kaggle. This dataset has a total of 4,000 images of flowers, which are divided into 5 categories, namely daisies, dandelions, roses, flowers, and tulips. I download them locally and train them. Firstly, the dataset is pre-processed and divided into 8.2 training set, verification set, and test set. The training set is used for model learning. The validation set is used to adjust the hyperparameters and prevent overfitting. And the test set is used for final performance evaluation. Secondly, use PyTorch image folder class to load the image dataset and perform a pre-processing operation on the images. This includes resizing the images to exact pictures, converting the image to PyTorch tensor, normalizing the image. When selecting the algorithm for model training, I choose CNN and use the existing pre-trained model MobileNet v2. The reason for this is that it can reduce the computational complexity and the parameter amount of the model while maintaining a very high accuracy rate. At the end of the function, the number of output categories is modified to 5, which is used for the classification text of 5 flower types. Next, I start training the model. I use the training dataset to train the model. The process involves forward propagation, loss calculation, back propagation, and weight update. Secondly, the test the performance of model on the validation set and adjust the hyperparameters such as learning rate, batch size, number, and the size of model layers. After my trainings, it was finally determined that the learning rate of 0.001 has the best effect. For the choice of optimizer, I tried SGD and ADAM, and I finally decided to use the ADAM optimizer. After training is completed, save the model as a file for use in the application, and I generated a line chart for train accuracy, valid accuracy, train loss, and valid loss at the same time. Then I wrote a function min1, which accepts input image, performs pre-processing, and then uses the train model to predict and return the type of flowers. This completed the deployment of the model. Finally, I used the PyQt5 to write a UI interface code as a user contact point to host the entire project. Integrate previously saved model into my app. When users select an image and click to recognize, the app should call the prediction function and display the result. Adding additional features such as flower language explanations. To summarize the entire project, the model accuracy in the validation set is approximately 91.96%, and its prediction performance in the application is good. Flower pictures randomly downloaded from the internet can be accurately identified, and the error rate is 0 in multiple experiments. Next, let's enjoy the operation of the application.
'Cause every time we touch, I get this feeling. swear I could fly. Can't you feel my heart beat fast? I want us to last. Need you by my side. 'Cause every time we touch I feel the static. And every time we kiss I reach for the sky. Can't you hear my heart beat so